So rational exponents. Now, again, from earlier, the word rational in math means a fraction. And as you can see, all these exponents are fractions. Now, a couple things before we do these, just remember, we talked about roots already. When we talked about the sum and difference of cubes, the SOAP factoring there, I reminded you what other roots other than square roots are. Like a cubic root is a number you multiply by itself 3 times to get the number that's under there. Like the cubic root of 8 is 2, because 2 times 2 times 2 is 8. And I mentioned, there'd be 4th roots, there'd be 5th roots, and you can have any root you want, basically. And all they mean, like the 4th root, what number do you multiply by itself 4 times to get the number under the radical? We also mentioned square roots then. That's the standard one. If you have a square root, you don't write the 2. I mean, you can, but you don't really. It's like x to the first is x. I mean, x to the first is right, but you don't write it. You just write x. Now, the reason that it's 2 and not 1, there's no such thing as a first root. That'd just be the number itself. So just remember, square roots, you don't really write the 2. You can, you don't really want to. So the way you do these, and the reason that I mention roots, there's kind of a saying to use for this: raise over root. When you raise something, you put it up. So that's how you remember raise is on the top, and root, like the roots of a tree, that theoretically, hopefully, are on the bottom of the tree. Raise over root. So what this means, like on number 1, the 5 is what this is raised to. Just like before, 6 to the 5th. 5 is 5 over 1, so you've always done that. Like the number on top is the regular exponent that you've always thought about your whole life. So this whole thing is raised to the 5th. 3 is on the bottom, that's the root. That's done. That's all at once. Number 2, write it as a radical. Raise over root, well, it's raised to the first power. I can write that down. I don't really have to, but I will just to illustrate here. And then the number on the bottom of the fraction is the root, 4th root. This part is really supposed to be easy. It is this easy. So 3, raise over root, it's raised to the 3rd power, it's the 4th root. Number 4, raise over root, so it's raised to the 5th. Now, it is the square root. Like I said, you can write the 2 there. You don't really want it, though. So this is just... that right there is the better answer without the 2. If you wrote the 2, though, it's okay. Now think about what it means, just to the 1/2 power then. P to the first is just P. I don't really need to write that down. Raise over root, that means it's the square root, but I don't really write the 2 down. So what this means, 1/2 power means square root. One-third power would be cubic root. 1/4 power would be quartic root. Now, like I said, I mean, this should be that easy. It's just write a radical down, put the base in there, slap some parentheses around it, put the number on top basically, and then the number on the bottom in the radical for the root. The other way around, this should be pretty easy too. That's raised to the third power, and it's the fourth root. On 7, that whole thing is part of the radical, so just make sure you use parentheses. It's the 6th root, so that's on the bottom, raised to the 5th power. Done. It's raised to the 4th power, so that's on top. The 5th root, so that's on bottom. Now 9, just remember, it's not written there, so it's a 2. Square root. So that's p. It's raised to the 3rd. It's a square root, so 2's on the bottom. Now on 10, there is no exponent that it's raised to, so that's like a 1. Just like 3 is 3 to the 1st. X is x to the 1st. So that right there is raised to the first power, and it's the 4th root, so 1/4. Those are that easy. They should be that easy. Now, equations with them. What you want to do first off, if there's anything that is not part of the base, if there's anything that doesn't get the exponent, cancel it out. Well, on 11, we don't have to worry about it. You want it to, all you have is the base and then the exponent. Then the second step, raise to the reciprocal. Reciprocal of 3 halves, it's 2/3. Whatever you do to one side, do to the other. Now, the reason you do that, you think way back to the beginning of the semester, think way back to algebra, think back to pre-algebra. On that left side there, you're raising a power to a power. When you raise a power to a power, you multiply. And think what happens when you multiply something by its reciprocal. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1. That's just x to the first, which is just x. So that basically just cancels it out. Then, just type the other side in to your calculator. Sorry, it took me a while to get the calculator to display. There we go. All right. Now we have 64 to the 2/3, so 64. Exponent button beneath clear. 2/3 will do it. 16. There we go. Now we'll go back to the so that's 16. So 12. On 12, okay, all we got is the base and the exponent, just like we want. Raise to the reciprocal. Cancels. Then you just type in 16 to the 3/4. That one's 8. $13. Okay, again, hey, all we got there is the base and the exponent. Raise to the reciprocal, 2/3, 2/3. That cancels the 3/2 out. Type it in, 729 to the 2/3, you get 81. 14, raised to the reciprocal. Reciprocal of 3/1, or excuse me, 1/3, 3/1, which is just 3. That's 125. Now 15, and we're gonna have to add a step up on the procedure up there. We have an 8K this time. Now, to start off, it's okay. Both the 8 and the K are getting that 3/2. So we gotta raise to the reciprocal yet again. 2/3. But here, this time, so that just cancels out. You still got an 8K left. So we raise 512 to the 2/3 power. And that gives us 64, but since we got that K there, if there's anything else in parentheses getting the exponent, you got to cancel it out at the end. That hasn't happened yet, so here we'll divide by 8. I mean, I probably wouldn't even have to tell you that, but just to be safe. So we'll go back up here. If anything else remains with your variable, cancel it out. I mean, you're not gonna have a ton of work really ever at the end. But if there's anything stuck on the variable, cancel it out. Now 16, now be careful. That 4 is not getting that 3/5. It's a separate term. So here we actually finally have to do the first step. I can only have the base and the exponent. So I'm going to minus 4. Now raise to the reciprocal, 5/3, 5/3. Then we just type in 8 to the 5/3 power. Again, it's just 8, then the exponent button beneath clear, then just 5/3 will do it. 32. 17. Nope. Well, again here, there's a 5 that's not getting the exponent. It's a separate term, so I got to subtract it. R to the 3/2 equals 27. Raised to the reciprocal, 2/3. 9. Well, there's a minus 27, but the difference here than the last couple, that 27 is in the parentheses. So it is getting the 7/5. So first off, I do raise the reciprocal. That 27 is part of the base. It is getting that exponent. So this time I raise the reciprocal first. Cancels. Now I got to type that in. So we got 5/7, 128 to the 5/7 power, 32. That equals x minus 27, because that's still there. All the 5/7 on the right side did was just cancel the 7/5 out. So now you got to plus the 27, 59. Now the equation's clearly a little bit more involved than the front side. But the front side should be that easy. Raise over root to switch back and forth from radical. The questions that you would see if you had regions would be basically here, there it is. Switch them. Tell me which choice matches. The back, the equations, a little bit more to it. Just the procedure there, the only real new step is raising to the reciprocal. But the idea, anything not part of the base, not getting the exponent, cancel out first. Then raise to the reciprocal. Then if there's anything left over, like the minus 27 on that last one, then cancel that out, using the same old algebra rules you've always done. Only new step really is the raise to the reciprocal. Hopefully that wasn't too bad.